Today is a beautiful day for science. Currently, we're looking at a coronal mass ejection that's departing with a beautiful spiral motion due to the helix formation caused by the magnetic field lines as they are twisted by the faster rotating center of the sun to the northern and southern portions. The sun rotates approximately every 25 days in the center, while 34 days at the north and south pole. And these are the GOES satellite imagery from NOAA, showing a beautiful presentation of this coronal mass ejection as it departs. This does appear that it will be impacting Earth. It is having a mostly northern direction departure, but it does appear that it will be also impacting Earth. But it will take some time for the SOHO satellite with the LASCO C2 and C3 imagery to be able to discern exactly how fast this is traveling and how soon we will be anticipating its arrival. Yeah, I was going to just sit here and be quiet and hold my puppy. Someone said, hey, you should say something. Don't know who that could have been. I love sharing science. It's a beautiful thing. Indeed, no flare. This is an eruption, a filament eruption. It loses its footing from the photosphere, and you can see the ripple effect. Where's my little Kerbalian? Get my Kerbalian. This is Mark Rober's Kerbalian. I named him after Mark Rober, the scientist, one of the engineers that worked on the Mars rover Curiosity. And yeah, right here you can see this ripple effect. This is all from the release where it lost its footing and caused the eruption. Or that's where the eruption focal point is. So as that happens, Loki is a little bit excited. Now he's laying at my feet again. The eruption occurs. You can see the ripples, the waves here of that plasma and the departure. And what's going to cause this to have more of a downward motion at the end here is the fact that this southern portion is exactly where the foothold remains, which is going to cause somewhat of a whip effect. If you remember the herbaliscence comment I made a while back, that my mother and I used to joke that some of these coronal mass ejections had an herbaliscence effect where it's like it's whipping its hair. Well, in effect, this is kind of what's going to happen, but we can't see it because it's towards us. So it's going to have a really nice effect where this mass, while we see more northward movement, is actually going to be a little more direct than as north as it looks due to that very effect. The footing still remains on the southern portion and is then dispersed and replaced at that point, where we'll start seeing the effects more on the surface. As time goes, the imagery updates much faster on the GOES satellites because they're not as high resolution and don't have to go through as much of a transfer from one database to another. And due to the fact it's actually NOAA's satellite, so it's much faster for them to upload their imagery. The SDO imagery is a little bit laggier, slower to update due to the fact that it's a much higher resolution and it has only one focal point, so it quite often has to receive and download its data from where it's at, which is in Texas, but then it has to transfer that data to the database, which is in Stanford, California, in which sometimes causes delays as we see these days. So if you're ever wondering why SDO imagery is not as quick to pick these things up as GOES, it's simply that the SDO has a middleman, as it were, to transfer the data, while the GOES is right to the source for the most part. In addition to the resolution difference. Now what we're also seeing at the same time is another event occurring here. We can see some plasma inflowing to the region and then a burst. So this again is also an eruption, not a flare. And we're seeing plasma displaced. But this plasma will go it will go forward of Earth's orbit, not projected towards Earth at all. We're starting to see the ripple effect a little more on the surface now. So as this filament is erupted from the northwest area here, you can see where it departed from the surface of the sun, where loops had interchanged somewhat throughout that region, or the area of this, and you can see that nice line of hotter plasma that's now laid bare to where it's going to actually have some small loops that form that almost work like stitches, as it were, and will either close that area up or have just loops for a little while as it then closes the area up. It's all just a matter of timing at that point. Waiting to see the actual impact right here. Once it reaches here, that is when it has been pulled from the actual southwestern, or more closer to the equator, or actually strike zone itself, however you want to phrase it, of the Earth-facing disk. Once that shows impact, that is when we're seeing the full launch. And again, looking at another of GOES angstroms here, filters, this one shows a little bit better in my opinion, because you can see the wider contrast to that darker blue, where the exact thin line, that refined point of where this filament was seated. Now, the red sun was angstrom 304, and that sun, it shows more of the surface and the filament itself. This one is more of the corona, and the exact angstrom filter is give me 1 second, I forgot the exact filter, how many angstroms each this is in. 284. So 284 angstroms, which is more of the corona. So this is very comparable to, I would say, probably like the mix of 335 and 193 in between there. So this gives us a little more view of the upper corona, as it were. So in seeing in the upper corona, you can see how this the splash effect is a little more isolated. It's a little more bright, vibrant, but it's also it's less defined, as it were, because it's more of like the atmosphere, clouds. Oh no, I didn't add the specific angstroms for GOES because the SDO angstroms filters, they typically cover the range well enough to decipher what it is. Additionally, I have not looked and seen exactly what definitive mention NOAA has put for theirs. That's a good question. All right, here we go. The 284 angstroms filter is an extreme ultraviolet image that shows and reveals ionized iron, Fe14, to Fe15 actually, rather. So which forms at temperatures of 2 times 106 Kelvin, flows along the magnetic field lines of the solar active regions. Look at that beautiful splash effect as we get further going, where that fine line that we did see is starting to separate even further because the amount of energy going through the corona causing this. And once again, it's not as detailed as it is on the surface of this wave because the corona is like the sky for Earth. It's more of a dispersed atmosphere, as it were, compared to the surface of the sun, where nothing really has much space to move. And it's all collisional plasma. So everything's running into each other, causing this fusion and the energy to release in the luminescence, radiance. It looks like we have a nice little plasma movement happening on the western limb as well. Or the eastern limb. Sorry, I got it backwards. On the eastern limb. So both on the right here, the eastern limb, we have this occurring, In the strike zone, we have this beautiful CME right here. And then on the western limb, we have this. I'm feeling pretty good today, all things considering. I've actually been able to sleep. Yay! But as I was saying, you see more of a defined wave effect. If I can actually pick right there, we go. More of a defined wave effect on 304 as it's on the surface, and it's more of it doesn't have that freedom to move as much as it does in these plasma does in the corona. So we see this exponentially expanding mass from the CME, and yes, this right here, if you look right here, you see this is coming right there directly towards the camera. That is the camera that's being used as the GOES satellite. That means it's coming straight towards Earth. That is going to be a precise impact right there. This does a swirling motion, and it comes all the way to this point right there, and that's right towards us. It's quite beautiful. Well, it's because as it exponentially increases its volume, or not volume, its coverage, its surface area, it spreads to up to 31 million miles from one point to the other in every direction. So you're talking about like a 31 million mile diameter cloud that's just departing, and it all started as just a very, very small comparatively. Of course, many times the size of Earth. But yeah, if this remained its own density and did not become a non-collisional plasma in its transversing through, it would decimate anything it ran into. Again, note the beautiful spiral effect that's occurring here. Twofold. What's happening is, once again, because that rotation of the sun causes the twisting of the magnetic field lines, which coils around the plasma, and additionally the fact that only the northern region was released from the photosphere, and the southern region is getting tugged and causing that to uncoil to some extent. And that is why we get that beautiful spiral. So it's like you spin a rope multiple times, and then you release one end of that rope. It's going to start spiraling as it extends further out. So it's uncoiling to some extent from that winding the sun has done by the way it rotates as it departs from one end until it starts tugging and completely pulls out that other end. And we'll see that here probably before too long. Hopefully that made sense. If not, just go ahead and tell me that it sounded too incoherent. I do not mind. The bit about non-collisional plasma. Okay, so when the surface of the sun is all collisional plasma. A good example of collisional plasma is like your lightning strikes. That's collisional plasma. But imagine the sun is all that, 100% collisional plasma. And it's because the intense density and gravity involved is not allowing any space for this plasma, which is a charged gas, to behave in the manner that's typical of gas. So it's stuck in almost a fluid type motion where it doesn't have that freedom. So that's why you get these nice wave effects and ripple effects that are more defined as opposed to what you would see in typically a gas. However, once this plasma in a coronal mass ejection that we're seeing, such as here, starts to depart that surface of the sun where the density is pulling it in and causing that fusion to occur and the irradiance to be extremely bright, it then starts to cool off very rapidly and spread out because it's got room now. And a gas does not like to be, and this is being a plasma, which is a charged gas, does not like to be that close to one another. So it eventually gets to the point where none of the particles of this coronal mass ejection are touching. In fact, the only way that they communicate to one another to maintain their form is through their electromagnetic energy. So they actually do maintain their polarity and their structure, but they do so without ever touching one another. And that's non-collisional plasma. When non-collisional plasma gets into the Earth and it hits the, say for instance, the geomagnetic field, the magnetosphere that protects Earth, it's impacted by this CME. Now, we aren't hit by the CME directly. It hits that magnetosphere. It absorbs, it deflects, and transverses it onto basically the tadpole tail, I like to call it, because just like a solar flare are two field lines touching each other, or even the same one touching itself at a shorter route, causing a reconfiguration, a flare. Our magnetosphere does the same thing. As that tail extends from saturation of all this coronal mass ejection activity impacting the magnetosphere, it extends further and further and further until the shortest route of transfer of energy is actually going to be closer to the Earth, as opposed to all the way going through the whole tadpole tail. And just as a tadpole tail can break off, so does the saturated point of the magnetosphere. When that happens, though, like taking a rubber band, putting it into the ocean, and splashing that rubber band, that tiny bit of water that comes back, a little bit of that plasma from that saturation also gets thrown into the northern and southern hemisphere polarity, geomagnetic dipole, of the Earth. And when that happens, it causes the aurora to occur. Now that aurora is that non-collisional plasma. Nothing's touching that plasma, one particle to the other, but like a spider web, where all the webs, the crossing points, that's the particle. Where all the webs are the pathing point between crossing points, that's just the energy itself from each particle. And whenever you touch a corner of that web, and it causes that whole web to move, that's what's happening as the atmosphere impacts and interferes with that plasma, that non-collisional plasma. And in reaction, we get the aurora. Yeah, so this is definitely going to be earthbound. Exactly how much, it does look like it's a good amount, but exactly how much and how fast is going to mean a lot to know what to expect. That information will take time to acquire based on the fact that it has to get beyond the atmosphere of the Earth or the Sun completely, and it has to reach to the outer boundaries of the occulting disk on the LASCO C2 and LASCO C3 satellite imagery from SOHO, and in which then you can actually measure, and there's a tool on one of NASA's sites where you can actually measure the speed approximately of these coronal mass ejections to estimate the time of arrival that it'll impact Earth. So anytime you hear someone say it's going to arrive in such and such time, they're just using that very basic tool that you can do it from the stereo ahead imagery with their core imagery, or you can use the LASCO's core imagery, which is LASCO C2 and C3. All right, just had another update. And you can see as this image comes out, you have an additional spiral motion starting, and you're starting to see more impact now on the other footing. This is where the other portion of that filament is reaching down through the surface of the sun and connected to the photosphere. So how that reacts coming up here soon will be very telling. And additionally, we're seeing the loop formations, as I was talking about, that's going to stitch this area back together. It's going to be quite beautiful. Well, this one's going to be a great one because this one's not as northward as I was originally expecting. This is coming with a nice whiplash motion that's more central. And as well, it is precisely directional towards Earth. So, absolutely. It does not appear that it's currently on NOAA's prediction yet. Wouldn't expect it to. You would no way to measure its speed. All right, going back to the 304 angstrom for GOES, and we can see is actually taking a little bit of a deviated path here in one of the loop areas. It looks like that this filament might have pulled some plasma from beside it as well from the looks of this. Way I can see this is because this wave motion slightly curves and comes back to that unified position again. I think this is just a trajectory explanation. I don't see any, there's no way you could calculate the speed yet, nor the mass. I mean, we can see an approximation, but until we get better detail, and it's also going to be very difficult. We don't have a sight-on view, and this is why stereo ahead and stereo behind was such a very significant mission. It gave us a point of view that was not dead on, that was not straightforward. And it's like looking at headlights coming towards you. You can't tell how big